Hi, everyone. I'm Shantanu Thuli. I'm a principal product manager at Upsolver, and with me is
Hi everyone, I'm Yoni. I'm the CTO of Upsolver.
we're here to talk about streaming concepts. And today on the docket is exactly once processing. So, what is exactly once processing, Yoni?
Okay, so at a very, very high level, exactly once processing is actually quite simple to understand. It's that every event that comes in, I want to process it once. So I want the each event not to process it twice, not to process it three times, and not to process it zero times. So kind of very, very simple to understand the concept. Implementation is quite hard in practice. Um, so I think first of all, we should separate between kind of the theoretical limits, kind of the mathematical limits of what's possible, and the practical limits of what's feasible. So mathematically, there's no such thing as exactly once processing. It's impossible to achieve. There's no way to solve this problem. There are a bunch of proofs and things like that. You're just like it's physically not possible to create a system that will guarantee exactly once processing. Um, However, you can get around this and get the same result as exactly once processing if you make sure that all your operations are idempotent. So what does that mean? This is getting a bit more complicated. Um, so an idempotent operation means that if you apply the same operation twice, you're going to end up with the same result. So an example of an idempotent operation is setting a cell in a database to a value. That would be idempotent. I can set the cell to the new value, and then if I happen to set the cell again to the same new value, nothing's going to happen. Like I'm just setting it again. So it's not like nothing's going to change the second time. An example of a operation that isn't idempotent is adding one to a value. So let's say I have a value 3, I add 1, it becomes 4. If I were to run that operation again, it'll turn into 5. So every time I run the operation, it modifies the end state again and again and again. So if all my operations are idempotent, I actually don't really care if I run the operation once or I run it twice, because running it twice ends up with the same result as running it once. Um, there is a question around ordering. So, for example, going back to this database example, if I update a cell in a database with one value and then update it with another value that happened later on, and then go back and run the operation again and update it again with the first value, then I'm going to get the wrong result. So in this case, it wasn't the fact that I processed it twice that caused the wrong result, but that I processed it out of order, kind of not in the order that the events were generated originally. And it happened to be that I processed it twice, but that actually isn't what caused the problem. If I would have not sent the first event, so I would have processed it just the second time, I still would get the same wrong result. Um, so when we're talking about exactly once processing, which again, like there's no such thing in the world as exactly once processing. So generally what people are talking about is idempotent operation. So it's a combination of at least once processing. So I will never drop events, but I might process events more than once. And idempotent operations, which together look like exactly once processing. I'll stop here if there are any questions or clarifications that you think we should add.
Yeah, well, in the example that you gave, right? So if it's a plus one operation, that's not it's not idempotent, but that's the operation that I need to do. Right? How do I still get exactly once processing?
So generally, what you're going to do is you're going to wrap that in an idempotent operation. So if we think about a classic kind of database scenario, I would have a transaction. In that transaction, I'm going to do the plus one, and then I'm going to commit the transaction. And the database has a guarantee of idempotence of that transaction. So it'll either commit the transaction and kind of apply it once, or it'll commit the transaction and apply it, or it'll roll back the transaction and not apply it. It will never commit the transaction twice and kind of reapply the same operations twice within the transaction. So it's taking the entire transaction as a unit, turning that into an idempotent operation, and kind of wrapping what you're doing with that. But that adds a lot of overhead. That's not like easy for databases to do, and especially in distributed systems. Yeah, it's very, very, by the way, everything I'm talking about is relevant to distributed systems, of course. Maybe I should have started with that, but yes, in distributed systems should have prefixed all the sentences I've said up until now.
That makes sense. So the combination of idempotent operations at the database level, and the second piece was at least once processing. That's what gives us exactly once processing.
Exactly. Yeah. Yeah. And that would be true for a database. And again, like databases, they do a lot of work in order to guarantee that. And there are a lot of limitations because of that. So generally they have, like, let's say databases will scale up to a certain point, and at that point it either becomes too expensive or just not technically practical to continue scaling, and then you switch to systems that have lesser guarantees generally. So they're not going to do that, and then there's the question of how do you support this exactly once. So if you look at streaming systems, look at Kafka, for example. So Kafka has exactly once. So this is part of kind of on the tin, it says exactly once processing. So here they're doing something very similar. They're saying, well, okay, it's technically impossible for us to guarantee exactly once delivery of the data. So we're gonna, if you ask me for data, you might end up getting it twice, but I can guarantee that I'll give you the same ID for that event for each time that I send it. And then you on the client side can decide what to do with that and make sure that you don't reprocess the same event twice if you take care of your idempotent operations correctly. So kind of Kafka is doing their side, so they're not going to kind of generate duplicates that you can't identify as duplicates. And on your side, you need to make sure that when you do get duplicate events, you process it in a correct way so that you end up that your operations are idempotent. So a bit they're kicking the can over to you. They're saying, we're not going to ruin it for you, but you still need to do the work of making sure that all your operations are idempotent.
I think that makes
Again,
sense.
stop here. And yeah, okay. Um, okay, so really, when you're talking about the problem of exactly once processing, I mean, maybe we should talk a bit about why exactly once processing is important. So for like in the, let's say, business cases where it isn't obvious, um, sometimes it's just super important because, you know, I'm processing a bank transaction, and if I don't have exactly once, I might deduct too much money or or not deduct enough money. So I mean, in some cases, it's very obvious from the data that any errors in data, duplicate or otherwise, are going to cause large damage to the business. But even in situations where maybe my data is less kind of mission critical, let's say I have kind of a stream of website visits. And okay, so I have, like, you know, millions of website visits per month, and what happens if, you know, one of them gets duplicated? Why do I care so much? So it's true that generally the duplicates are going to be a small percentage of your data. So maybe 1 in 10,000, 1 in 100,000, something like that. So it's not like, you know, statistically meaningful when you're looking at kind of an aggregate of everything. But what it will do is it introduces small inconsistencies throughout your pipeline so that you can never compare apples to apples. Any comparison you do, like one table, my source data, I have a million records. One step down, I kind of cleaned up my data a bit, and suddenly I have 1,000,005 records. Another step after that, maybe I aggregate, and my aggregates add up to 1,030. And etc. As my pipeline expands, each step is going to have a different sum, kind of like there's going to be no easy way to compare them and say, well, actually, these two things represent the same thing. And now this is super important because then when you report it to the business, you can say, well, okay, error margin up to, like, you know, 1 in 10,000, we're going to get it wrong. That's fine. But then when you're trying to validate your own pipelines, I mean, is my calculation in fact correct? It's super difficult to do when the numbers don't add up. When kind of everything that I do, all my Excel sheets, all my comparisons need to be like, and the error bars, and, like, you know, maybe sometimes an average isn't going to be affected, but then something else will be affected in a more drastic way. Maybe it's a large event, and suddenly, like, you know, I have to add a bit of uncertainty into all my comparisons, which makes just data validation very difficult. So even if you don't care about the the 1 in 10,000 event that might get duplicated or lost, it's still very important just to be able to make sure that your pipeline has sanity. That's not getting into kind of streaming system quirks that can make these things get much, much worse than they start. But even just from kind of a very basic level.
Mm-hmm. Yeah, that really resonates with me, actually. At my previous job, my colleague and I would have a separate pipeline from the like production one, just as a cross validation against the data and insights that we provided, and we would very often have to do these deep dives into why a single number is off. So that makes sense.
Yeah, it's much easier when the computer can just do it for you. Like when you do A equals B and the result is true, that's like kind of very easy to pass on. And if the result is not true, then you have to add a lot of thought to that process. Yeah. So when we're talking about exactly ones, we're actually in the end we're talking about idempotent operations. We're talking about how do I make it that all the operations I do on my data, if I apply them again, I'm going to end up with the same result. Not because I care about idempotent operations, but that's de facto the way to reach exactly one's processing. Now, this introduces a lot of limitations on what I can and can't do in my ETL. So an idempotent operation, I apply it twice, it has to give me the exact same result. So writing a number or writing a file somewhere, that's idempotent. Writing a file to a location that depends on the current time when I'm writing it is not idempotent. Reading from a file is idempotent. Reading from a file, if it exists, is not idempotent because it might exist or not exist in different runs of the task. So suddenly there are a lot of things that I need to think about, both in my inputs, in my outputs, and in the internal process. Generating a random number is not idempotent, ever. Generating a pseudo-random number is if you set the seed for your batch in a consistent way between runs. So you really need to think about all of these things. Which functions can you use in order to be idempotent? Where can you write your data? Where can you read your data from? How can you ensure that what you're reading is in fact what you will always read for this same operation, regardless of network partitions or crashes or failures or whatever it is. But at the same time, your operation still needs to make sense. So if, for example, I'm saying, well, I have to read this file, and then suddenly it doesn't exist, am I just going to get stuck forever? That doesn't make sense either. Like I need to somehow recover from this new world situation. So, all of these things, all of these thoughts around how to make your pipeline idempotent, that's really what the data engineer should be focusing on. The exactly once comes from that, but you can't really tackle exactly once on its own. You need to tackle the idempotency and then just make sure that also none of the systems that you're consuming or writing to break that promise. So if I'm reading from Kafka, that's fine, but I need to make sure to actually turn on exactly once in Kafka. If I'm writing to snowflakes, I have to make sure that I'm writing in a way that will guarantee idempotence. So everything that I do, I need to make sure that it follows that. And yeah.
Awesome. Well, we covered why you need exactly once processing and how exactly once processing is achieved, even though it's a mathematical impossibility. So with that, we'll sign off. Thank you so much, Yoni.
Thanks a lot.